If someone offered you $10,000 today or $12,000 3 years from now, which is the better deal? The answer depends on one of the most important concepts in finance, present and future value. And by the end of this video, you'll know exactly how to figure it out. So here's the core idea. When dealing with cash flows over time, we're generally interested in one of two things. Either determining the value today of cash flows that occur in the future, or determining the value at a future date of cash flows we have today. In time value of money terms, moving forward is compounding. Moving backwards to today is discounting. So if I were to ask what $10,000 received today will be worth 1 year from now at a 6% interest rate compounded annually, I'm asking us to determine the future value of that amount. And since this involves just a single cash flow over 1 year, we can solve it easily. We take the present value of $10,000 and multiply it by 1 plus the 6% interest rate, giving us $10,600. That's compounding. And we can do the same thing in reverse. Instead of receiving $10,000 today, suppose we receive $10,600 1 year from now, and I ask what that amount is worth in today's dollars at a 6% discount rate. We solve this by dividing $10,600 by 1 plus 6%, which gives us a present value of $10,000. That's discounting. But those were very simple. Let's now build some intuition around how these calculations work so we can handle more complex scenarios. So back to our example of $10,000 received today compounded at 6% for 1 year. We calculated a future value of $10,600 by multiplying $10,000 by 1 plus 6%. But that's just a shortcut. What we're really saying is that on $10,000 we earn 6% interest for the year, or $600. Add that $600 to the principal and we end year 1 at $10,600. In year 2, we take the $10,600 at the beginning of year 2, multiply by 6% to earn $636, and end year 2 at $11,236. Do it again in year 3, and 6% of $11,236 is $674.16, bringing the total to $11,910.16. So notice the pattern here. In year 1, the ending amount equals the original $10,000 plus 6% of $10,000. So we could write that as $10,000 plus $10,000 multiplied by 6%. But if you look closely, both pieces contain the same $10,000. That means instead of writing them separately, we can do some basic algebra to combine them into a single expression, $10,000 multiplied by 1 plus 6%. And that's the shortcut. Rather than calculating the interest and adding it every period, we can multiply the principal by 1 plus the interest rate. So $10,000 times 1.06 gives us $10,600. But that's only for 1 year. Let's expand this to year 2. At the end of year 1, which we'll label T sub 1, we have the original principal multiplied by 1 plus the interest rate. To get year 2, we take that amount at T sub 1 and multiply it by 1 plus the interest rate again. So the total at T sub 2 equals the total at T sub 1 multiplied by 1 plus the interest rate. And since our figure at T sub 1 already equals the principal multiplied by 1 plus the interest rate, we could substitute that in. That gives us principal multiplied by 1 plus the interest rate multiplied by 1 plus the interest rate again, which we can write more compactly as principal multiplied by 1 plus the interest rate squared. And if we plug in our numbers, $10,000 multiplied by 1.06 squared equals $11,236, just as we calculated a minute ago manually. And we don't need to walk through the full substitution again for year 3. We would simply multiply by 1 plus the interest rate one more time. So the total becomes the original principal multiplied by 1 plus the interest rate raised to the power of 3. And with our numbers, $10,000 multiplied by 1.06 to the third equals $11,910.16. Again, the same figure we calculated manually. And now you can see the general formula for compounding a single lump sum into the future. The future value equals the present value multiplied by 1 plus the interest rate per compounding period, raised to the total number of compounding periods. In our example, we're compounding annually, So after 3 years, $10,000 becomes $10,000 multiplied by 1 plus 6% raised to the third power. But the same logic applies to any compounding frequency. If interest compounds quarterly, there are 4 periods per year, meaning the periodic rate is 6% divided by 4, and over 3 years there are 12 total compounding periods. So we calculate $10,000 multiplied by 1 plus 6% divided by 4 raised to the power of 12, which gives us $11,956.18 after 3 years. And notice that quarterly compounding produced a higher ending amount than annual compounding. That extra $46.02 comes from the more frequent compounding. Anytime interest compounds more than once a year, the effective rate you earn will be higher than the stated annual rate. The process for discounting is the same, just in reverse. The general formula for discounting is simply the future value divided by 1 plus the interest rate per compounding period raised to the total number of compounding periods. So returning to our annual example, if we were told we'll receive $11,910.16 3 years from now and want to know what that amount is worth today at a 6% rate, we divide $11,910.16 by 1 plus 6% raised to the power of 3. Doing so gives us a present value of $10,000. And I want to emphasize something here. While there are mathematical formulas involved, and many resources focus heavily on Excel functions, factor tables, or financial calculators, time value of money problems are not about memorizing formulas. They're about understanding how cash grows into the future or shrinks back to the present. The formulas are tools, but the intuition behind them is what's most important. So going back to our opening question, if someone offered you $10,000 today or $12,000 3 years from now, we now know that this is a return of a bit over 6%, assuming annual compounding. So if you feel that you could take that $10,000 today and earn more than that, you should choose to receive the money today. If on the other hand, you think a 6% return is acceptable to compensate you for waiting 3 years to receive the cash, you should choose to wait. And that covers the basics of present and future value.